Hi guys, welcome back to my YouTube channel IBwontcrushyou, and today we're dealing with transformations of functions. This is the topic that is only required for higher level, and it's rather challenging. However, I will do everything to help you deal with it. So let's get started. Problem 1. The function f equals x squared is transformed into g equals and in bracket x minus 3 squared plus 2. A. Describe transformation that maps f to g. And here you have a small cheat in order to help you with these exercises because sometimes they are a little bit tricky. So, firstly, our point A, transformation that maps f to g. So we can observe that firstly, something changes with our x, and here we have only x squared, and here we have x minus 3 squared. So here we have this. And this is horizontal translation right by c units. So this is our first transformation, and you can observe that our sign, so plus or minus, they only show us up, down, right, left. So that's it. And the second transformation is in here, so plus 2. So this is it, and we have vertical translation up by 2 units. So this is our answer. B. State the coordinates of the vertex of both f and g. So here we have to use our vertex form of our function, and it looks like this: y equals a, and in a bracket we have x minus h squared plus k, and these letters h and k they change because we can use also p and q. It doesn't matter. However, these letters are our vertex, so no matter whether these are h and k or p and q, these are our vertex. And we can observe that in our function f, we don't have this vertex form, so it means that our vertex is 0, 0, because it's a simple parabola, and you can graph it on your GDC, and you can observe that vertex of this function is just 0, 0. You can also graph gx, however, from this vertex formula, you can observe that our vertex, so here h is 3, and here is 2, so 3 and 2. Also, you can graph it to be completely sure. However, in point C, we have to use our GDC to graph both functions and verify our answer. So in B, we can use this vertex form and our knowledge that x squared, so a simple parabola, has a vertex in 0, 0. And now we have to graph them, so we have to type them into our GDC and then redraw them on our paper. So our functions more or less look like this. And D, how does the axis of symmetry change? And as you can observe, firstly our x-axis was 0, so our x-axis was in here, so 0, and then we have our x-axis in here, so in 3. And this can be our final answer. Problem 2, let f equals square root of x, define g equals minus 2 square root of x. A, describe each transformation applied to f. So we can observe that our function g is different because it has minus 2. So here we have our sheet. However, you have to remember that it's not on your formula. It's not in your formula booklet. So on your final exam, you have to remember it by heart. So we have minus 2 in front of our function. So here you can observe that we have a digit. However, in this case we have a letter, but in our case we have digit, so 2 in front of our function. However, we have also minus. So we have reflection and vertical stretch. So we have to write down both transformations. So these are our transformations, and in B we have to use our GDC to sketch both f and g. So we have to type both functions into our GDC and then just redraw them. So these are our functions, and as you can observe, our function gx is reflected over x-axis and is stretched vertically by this factor 2. So here we have 1 on our y-axis, and here we have minus 2 because it's firstly it's reflection, and then we have stretch by 2, and here also we have 3 on y, and here we have minus 6. So the same situation. Problem 3. The graph of f equals sinus x is transformed into g equals sinus, and in bracket we have 1 over 2, and in bracket we have x plus pi. Describe all transformations in correct order. So here once again we have our small sheet. However, you have to remember all these transformations. And firstly, our first transformation is something that happens next to x. And next to x, we can observe that we have x plus pi. So our first transformation, we have plus x, so we have a horizontal translation left by pi units. And after this horizontal translation, here we have 1 over 2. So we can observe that this is in front of our x, so here, and we have 1 over 2. So we take this horizontal stretch because our 1 over 2 is between 0 and 1. However, it won't be horizontal stretch by 1 over 2, but horizontal stretch by 2. Because this is a rule that when we have a horizontal stretch, so our stretch is basically the inverse of this digit that is in front of our x. So when we have 1 over 2, so horizontal stretch is by 2. And it works like this. So this is our final answer, and you have to be very careful in this type of exercise in these transformations, because they sometimes make you a lot of trouble. However, I wish you luck with them. Problem 4. Let f equals absolute value of x and define g equals minus 3, and in absolute value we have x minus 2 plus 5. A. Describe the sequence of transformations from f to g. And here also you have a small sheet. However, you have to be sure that you know these transformations by heart, because as I previously said, you don't have these formulas, let's say, in your booklet, so it's important to remember them. And we have to describe the sequence of transformations, so step by step. Firstly, we're considering what's going on right next to x. So we have x minus 2. And we're looking at our small sheet, and we have x minus c. So like in our absolute value, x minus 2, so horizontal translation right c units, so in our case, right by 2 units. Then we have to consider our negative 3, because it's closer to x than 5, because 5 corresponds to the whole function, and minus 3 is in front of our absolute value, so in other words, the bracket. So we're considering negative 3 for now, and here we have minus, so reflection over x-axis, and we have also a digit in front of our function. So we have here, we have vertical stretch, not compression, because we have a that is greater than 1, because we have 3, so vertical stretch by 3. And the last thing is our 5, we're left with 5. So our first, let's say, formula, vertical translation up by 5 units. So this is our point A, whole point A with these all transformations, and in B we have to determine the vertex of gx. So you can observe that our function g is like our vertex function for our vertex formula for our function. So here we have 2 and here we have 5. So our vertex is 2 and 5. Problem 5. Let f equals x squared minus 4. A, sketch f and y equals 1 over fx in GDC. So all we need to do in this point, we have to just type our functions into our GDC and then redraw them on the paper. So this is our graph of both functions. The parabola is our f, and the rest is this y equals 1 over f function. And in B we have to state the values of x where y has vertical asymptotes, and asymptotes are the lines that are never touched by the function. So in our case, you can observe, and we are only considering our y function, so not parabola. So here we have our first vertical asymptote, and in here we have our second vertical asymptote. So in B we have vertical asymptote for x, that is minus 2, and for x that is 2. And in C we have to identify where the graph has a horizontal asymptote. So we can observe that our vertical asymptote is only 1 and is here. So it is this is like our x-axis. So our horizontal asymptote is at y0. Problem 6. You're given graphs of 3 functions, fx, gx, that is f and in bracket x minus 2 plus 3, and h, that is minus fx plus 1. A, explain geometrically how each transformation modifies the graph. So yet you can use our little cheat, and we're firstly dealing with graph g, so gx, and we will write our transformations. The first transformation is next to x, so x minus 2. This is it, and we have horizontal translation right by 2 units, because we have minus 2, so by 2 units. And then we're left with 3, and this is our formula that we are taking, and this is vertical translation up by 3 units. And that's all with g. Then we have to consider our function h, and we can observe that firstly we have minus in front of our function f, so we use this, so reflection over x-axis, and we can say that we're left with 1, so we take also vertical translation up by 1 unit. And that's all for this point A. And in B, if the point A has coordinates 4 and 5, lies on F, find coordinates of the image A on G and H. So you have to imagine that we have point A with coordinates 4 and 5. So A has 4 and 5. As always, our first digit in the bracket is x and the second is y. And we will start with gx. And our transformations are horizontal translation right by 2 units. So right means that we're considering x, because also in here we have something with x. So our first, from our point A, we have 4 as x, and we translate it right by 2 units. So basically our G A, the first coordinate will be 4 plus 2, so 6, and y is 5 in on our point A, and the vertical translation up by 3 units, so we have to add the 3 to 5, so 8. In H we have a little bit different situation, because we have a reflection firstly. So when we have reflection over x-axis, so our y changes the sign, because only our y is reflected. For example, we have a point with coordinates 3 and 3, and we're reflecting it by over our x-axis, so our new coordinate will be 3 and negative 3. So only y changes the sign, so we will have 4 and minus 5 after the first transformation, and then we have vertical translation up by 1 unit. So vertical translation up corresponds to y, so we have to add 1 to our negative 5. So our final answer will be 4 and minus 4. And that was the last exercise from this transformations of functions topic from functions chapter. And if you found this video useful and helpful, please leave thumbs up, subscribe to my channel, and in case of any questions, you can write them down in the comments down below or via my mail that is in the description of this video. And see ya!